Okay, good evening everyone, and I guess it's time for more Rust. So, okay, today's moderator is going to be Hebi. So Hebi, thank you for being here. And I'll also be looking at the chat, so yeah. It's like something I've learned, but like looking at the chat during these live streams is like absolutely super useful because like you folks have a lot of good tips and a lot of like what you're saying is like helping me in what I'm doing basically. So I didn't do any Rust like from when did we meet last time? I think Thursday, right? Something like that. But it was because no, even Wednesday, so I barely remember anything. We are not going to do linked list today, no, because like I failed last time, but yeah, I just like don't have the tools to be able to implement linked lists basically. And what I'm going to do today is I'm going to, well, basically start learning what are these like references and like borrows and stuff like that, and like how does it work? What are the rules? Like what are the official rules for that? And how do I use it, right? Because it seems to be like one of the key features of a language, and I don't think I can progress further if I don't learn it. So that's the idea basically for today. Yeah, and I wasn't doing any Rust because I was hacking satellites. So our team got second place in the finals of Hackasat at DEF CON. And it was fun because there's an actual satellite going around the globe, basically, which we were hacking. It was like called Moonlighter. And yeah, like playing with satellites is pretty interesting. If you're curious about it, like what the competition was about, like just go to hackasat.com. And where like you can read or watch some videos here, or you can go straight to the AF Research Lab YouTube channel, and they're like basically these videos on top. If you go to the video section, like you can learn quite a lot about like what the competition was about. So yeah, Poland came into space, got kind of into space. We got second place, but yeah, I didn't want to talk about or chat about this today, because this we are still discussing with the team, but we are thinking about doing maybe a podcast, or maybe like just like something like chat about it a little bit. So that's like a topic for another live stream, because today we are doing Rust. Okay. Yeah, like speaking of linked lists, by the way, like one thing we discussed later on my Discord. You can, by the way, if you want to join our Discord, like there's a link in this bar on the bottom from time to time with a link to the Discord. Yeah, like that. In reality, you don't really use or implement linked lists. Like you rarely use linked lists in real programming. You usually are using like something like vectors or like what Python, for example, calls lists. That's just vectors in C++ terminology, which is basically a glorified array. So yeah, in reality, you rarely use linked lists. There are like some low-level places, like the lower level language, the higher the probability is that you would be using linked lists of this or that sort. But yeah, like I did choose linked lists because it was like something that came to my mind. And also you folks on the chat said that, yeah, it's like, yeah, you cannot do it in Rust because it's just like a little bit, yeah, convoluted. And I couldn't have done it, and I then implemented it, implemented it by, or rather transcribed it from somebody who implemented it, and they were using like a totally different approach, which I kind of understand with reference counters. Which is weird, like why would you use reference counters for a linked list, right? Like if you ever implemented a linked list in C++, then you know like how to do it. It's pretty easy. You just use pointers, and yeah, it's trivial. It's like what you teach people on like lesson 1 of algorithms, basically, or other data structures. And in Rust, that's apparently not the case, but you also don't need them that much, and I think the standard library has them. Anyway, but that still showed me that, yeah, I probably need to learn that borrow checker and how does it work, because that is an important piece of a language. I imagine it to be like pointers in C, basically, but like that's a thing which you maybe can work around a little bit, but at the end of the day, if you want to be good at the language, you need to probably learn it. So let's look for some resources for that. Basically, I guess like Rust documentation is going to be a good one. So maybe Rust barrow checker rules. Let's start with that and see where we get. Will the podcast about satellites be in English or Polish? We'll see. I don't know yet. If it's going to be in Polish, then I'll make a separate like a live stream with probably like one or two other people to do it in English anyway. Cool. Let's go with rules, and I think I need a section for the whole thing. So give me this. Where do I put it? Various stuff. Let's just make another section, I guess. Barrow checker. Okay, like, and I guess rules, like official rules is going to be the first thing. Cool. Rust C dev guide. This is the compiler development guide. Mir. What does mir bar? I don't know what's mir. There's apparently mir and here. Okay, whatever. Yes, this is reading documentation live stream. Welcome to my reading documentation live stream. The barrow checker is Rust secret sauce. It is tasked with enforcing a number of properties that all variables are initialized before they are used. That makes a lot of sense, actually. So rules. Let's just like grab this as a source here, and then I might be like looking at other sources later on. So all variables are initialized before they are used. Okay, all variables must be initialized before use. Thank you very much, AI, for finishing the sentence for me. Variables, yeah, exactly. But you cannot move the same value twice. You cannot move the same value twice. I don't know what that means. Yeah, let's probably do it like this and do this like this. Can I hide this window? No, I cannot. Okay, that's fine. Okay, here we can hide this though. Can't move the same value twice. Do they mean that like if I have a value and I move it? Okay, so I understand moving currently as the concept from C++, which is basically we have an object, right? And the object basically describes like some huge buffer in memory, like 1 GB, right? And you have like another object which doesn't have a buffer. And you want to transfer this buffer to that buffer, then the transfer which basically moves it to move, like takes the buffer from this object and moves it to the other is called moving, which means that the buffer is no longer there in the first object. Instead, you get a null value basically in its place, like nothing. There's nothing left, right? You just like the shell basically, but you moved the whole large buffer into another object. And this is really useful when you have some data which you don't really like. It's large and you don't really want it to be copied between objects, right? Because you know that, yeah, I don't need it anymore in this object because this is like an object like an object which is like just temporary, for example. But whatever object is going to need this, I'm just going to move the data there. And this is called moving. Now, if they mean that you can't move the same value twice, is that if I moved the, you know, whatever was the large buffer from the object somewhere else, then I cannot move it again somewhere to another location. Well, that makes sense because it's no longer there. It might have a different meaning though. For example, like if I moved it to this object, I cannot move it from this object anywhere else because reasons. I'm not sure what that means yet. So can't move the same value twice. To do, what does this actually mean? But you can't move a value while it's borrowed. Okay, this already clicked something in my head. So let me just rephrase it. I must not move the same value twice. Must not move a value while it is borrowed. Okay, so if we have an object, and this is how I understand it at this point. We have an object, and the object is the owner, basically, like has some buffer, right? Is an owner of some buffer, and then we are like using in some function. We are basically using this buffer. We are like that function borrowed the buffer, but it's not really that function isn't really going to, you know, like move the buffer anywhere else. Just going to modify it maybe a little bit, maybe just read it. and just leave it with this object, like the ownership basically doesn't change, then while I have a function or like that, or some variables, whatever, that borrowed that object, that are using that object, that means that I cannot move that object, because in a high-level language that would be fine, like all references would just follow automatically, right? But in a compiled language, that's a little bit, on a low-level language especially, that's like you don't want to implement that, right? So that makes a lot of sense. But like, yeah, if like something is using the data, then I cannot get rid of the data, because the moment I get rid of the data, like all references start pointing to a place in memory which probably doesn't exist anymore, or might not exist in the future, because the other object might just destroy the buffer. So must not move a value while it's borrowed. That makes a lot of sense. Also, another analogy which comes to my mind, I don't know if it's a good analogy at all, but is when you have locks, like in multi-threading, there's a mechanism which is pretty good, which is like read-only locks, meaning that you have some data which other threads want to access, but they want to access it only for reading. There's absolutely no reason for blocking them when they just want to read the data if nothing else is modifying the data. And here we are not talking about like reading and modification. Here we are talking about borrowing and moving, but the same concept kind of would apply. Okay, cool. Then we have that you can't access a place while it is mutably borrowed. Like, this is like really similar to like read lock, write lock, mutexi in concept. Like, these are like the same rules basically. Okay, must not access a place while it is mutably borrowed, except through reference. Except why is there such an exception? Except through reference. That's kind of weird. Why? Like, I don't get it. Why does the reference change here? Anything? Okay, but you cannot mutate a place while it is immutably borrowed. Must not. But that makes a lot of sense. If you borrow something as like const, as in like you say you declare that you're not going to modify it, then you shouldn't modify it. Must not modify place which was. It's interesting that they say place, not like a variable, but place, which was immutably borrowed. Yeah, in C++ was like it's the same. If you have a buffer, for example, and you pass it as a const pointer to that buffer, then because of this like const qualifier, it's immutably borrowed. Basically, you cannot modify it. Okay, I don't know what mir is or here is, but I'm guessing these are like some algorithms. A list of bugs. What's interesting? Tracking list for bugs. Okay, that's let's see if like that was 2018, which is fine. Let's see if this guy knows. So what's mir and here in terms of you don't see it. Terms of Rust borrow checking. Okay. In Rust, I'm showing memory. Let's see if like actually putting the same in Google wouldn't be faster. Mir is Rust mid. Yeah, that would be faster. Like ChatGPT 4 is pretty verbose, I guess. Mir is Rust mid-level intermediate representation. Okay, constructed from here. So okay, hey, that's interesting. What's the difference between okay, high-level IR and mid-level IR? Interesting. Where's my notes? Various stuff. Questions. There we go. Question. How do we get to mir and here? That's like mid-level intermediate representation and high-level intermediate representation. That sounds like a fun place to be. And we can figure that one out later. Okay, so apparently they went what? Okay, let's see what this guy said. I don't fully trust, like nobody should fully trust ChatGPT, of course, but it might at least like create some questions in our heads, which is a good thing. The sugared, what does that mean? Version of Rust source code. Ah, you like sugar syntax is removed. Okay, the sugared. The sugaring means syntactic sugars. Yeah, yes. Okay, removed. I probably should always read the second sentence in ChatGPT before I start asking stupid questions. For example, for loops transformed into equivalent loops using iterators. Okay. Hero maintains a closed role. Okay, so it's basically like a first pass after through the code. That makes sense. And mid is a lower level representation. It breaks code into simpler form where each statement represents a single operation. Okay, which means is like that makes a lot of sense. So it's like pretty similar to what Clang would do, I guess, when it's compiling with its like LLVM IR. Okay. Cool. Okay, and doing this on Mir is far less complex than on here. Yeah, I believe that. Absolutely, I can fully believe that. Major phases of barrow checker. The barrow checker source is found here. Did I link this? Did I make a link to this various? Yeah, I did. We first create a local copy of Mir, then invoke something. I don't think I need to go into this right now, but let's read it. We first create a local copy of Mir. In the coming steps, we will modify this copy in place to modify the types of things to include references to new regions that we are computing. We then invoke replace regions in Mir to modify our local Mir. Among other things, this function will replace all the regions in the Mir with fresh inference variables. Okay. Next, we perform a number of data flow analysis that computes the data, what data is moved and when. We then do a second type check across Mir. The purpose of this type check is to determine all the constraints between different regions. Next, we do region interference, which computes the values of each region, basically the points in the control flow graph where each lifetime must be validated according to the constraints we collected. At this point, we can compute the barrows in scope at each point. Finally, we do a second walk over the Mir, looking at actions it does and reporting errors. For example, if we see a statement like the reference a plus 1, then we would check that the variable a is initialized and that it's not mutably borrowed. But like somebody else did not borrow mutably this variable. Okay. As either of those would require an error to be reported, doing this check requires the results of all previous analysis. Okay. So it does magic, which makes absolute sense. Let's see just quickly. What's a data flow analysis? Okay, I know what's a data flow analysis. But I can go into details, but I'm not going to go into the details yet. I might go to the details later. So I'm just going to note that like here maybe note there are some links there. Okay, so that was the first document which I kind of found about it. Let me quickly look at the chat if there's any question or comment. Dimka writes, you have to look in the box leak stuff. Okay, what's box leak? Just two rules, Jovan writes. First, you you can have only one mutable pointer to many read or many read-only pointers, and second is borrowing, transferring ownership. Okay, so borrowing isn't if I understand this correctly, what they've written here, like borrowing isn't transferring ownership, right? It's like maintaining ownership, just like borrowing. Or maybe it's like temporary I guess like you can say it's temporary transferring of ownership, but that's not fully true, I guess. The Windows process list is just a linked list. Yeah, that's true for a lot of things, like in Windows, especially on low level. Like, for example, the list of loaded libraries is also, I think the list of drivers is a tree. It's a little bit more complicated, actually. There are like multiple ways you can view a driver stack, but let's not go over maybe. Gerben writes, malware viruses hide themselves simply by removing themselves from the linked list, so connecting the previous and next up. Yeah, that's a typical rootkit, absolutely typical rootkit thing to do. I think like modern Windows is actually try to protect against that, but yeah, that was like classic textbook rootkit, basically. Okay, Rust book. I should learn from Rust book, which I will look in a second. Don't look at Mir. Mir is intermediate. Why not? Like, intermediate languages are fun. You're reading the wrong book. I'm not reading the wrong book. Like, the thing is that... Okay, so it's like this. My philosophy when it comes to learning, right, is to read as many sources as possible and learn from as many sources as possible. So what I'm likely going to do is now I'm going to go to the Rust book, which you folks recommend. But that doesn't mean that this was wasted time, right? Like I might have learned something, I might have picked up something. Maybe I picked it wrong, but then like some questions would spawn in my mind. So yeah, don't worry about it. Like this isn't time wasted, and I will likely look at multiple other pages, and likely in the evening I might like watch 1 or 2 talks about how borrow checker works at Rust. Like as I said, basically like I'm going to learn Rust on live streams, but there will be sometimes from time to time I will be saying that yeah I'm going to watch this, or that I watched this between the live stream. I'm not going to do any coding between live streams, at least not now, but I might be reading or watching stuff, but I will always let you know what. Cool. KrzaQ writes, what is the reason for discovering new programming languages? Just use C++. C++ is evil, and I'm already coding in C++ for 20 odd years. So yeah, I like learning a new language from time to time. Also, like C++ is an evil language. Like I don't think new software should be written in that language for security reasons. It's just too hard to understand C++ for most programmers. And even like experienced programmers will make mistakes which lead to security issues. It's just not a good language. Like at the end of the day, I'm sorry, I love C++. I've written a lot of code, really a lot of code in C++, but it's just not a good language. Like there are issues with it. It's just too hard. It has like pros and cons, of course, like, but yeah. But at the end of the day, it's not a language we should continue to be using. At least not in the current state. Maybe like C++ 27 will be like a subset of C++, which is actually makes sense to use. Cool. Let's go to Rust book. Borrow checker rules. Here. References and borrowing. Perfect. The issue with the tuple code, I'm guess like listing 3.4, where's listing 3.4? Okay, here. Is that I'm guessing like I should have read something. Yeah, understanding ownership, let's go there. But before there, I actually have one question. Like, what are like variable types at the end of the day in Rust? Because like in a lot of languages they're like basically 2 groups. They're like complex objects and like plain old data, like simple variables, and they behave differently. And I'm wondering like what's true for Rust. So let's go with this one. Let's start with here. Basically, I'm just going to link it maybe here, and I'll link specific chapters later on. So, common programming concepts. This chapter covers programming concepts. Perfect, good. Variables, storing values with variables section. The default variables are immutable, which is good. I like it actually. In C++, I try to use const keyword everywhere anyway. This is one of many nudges, to write code, which is fine. However, you still have the option to make your variables mutable. Let's explore how and why Rust encourages you, which is kind of funny because like when I was transcribing the code, I noticed that in Rust you can basically overshadow the variables. Like declare the variable of the same name twice in one function, in one scope, which is, that surprised me a little, but it's at the end of the day, I think it's a good thing. Like when you're done with a variable, you just like, but you need something named in a similar way, just do it. Let's explore how and why Rust encourages you to favor immutability and why sometimes you might want to opt out. When the variable is immutable, once the value is bound to a name, you can't change it. To illustrate, generate a new project called variables in your project directory. Okay, let's do that. Let's actually do that. Where's my Rust directory? Here it is. Cool. Let's follow the exercises because why not? I'm already bored of variables. Yes, exactly. Variable is a variable which writes in a car, in case you were wondering. So let's go to variable source and let's open that main. Okay, there we go. Let's make it a little bit bigger. And what do we have here? Okay, then in your new variables directory, and okay, let's transcribe it. Function main let x equals 5, print ln the value of x is x. Oh, I can do this? Okay, interesting. Did we use it before? I thought we were doing something like this before. Huh, okay. X equals 6, print ln the value of x is... this makes sense because I know that this is constant by default, immutable if you will, by default. And I really need to figure out how to convince it that I actually want 2 spaces and not 4. Okay, and we do cargo run, and it will say, like, how about no? Cannot assign twice, that makes sense. Okay, cool. Yeah, it complains. The example shows you, okay, experienced what? Rustians? Rustenians? Rustasians? What is this word? Okay, Rust programmers, this is what they mean, right? Still get compiler errors, you receive... Okay, I don't understand this concept. Then I just do moot. And if I understand correctly, I need to place moot in this order. And I cannot do like moot let, right? No, this doesn't... sorry, let me make it the console a little bit higher. This doesn't work. Can I do something like this? No, it really has to be here. There are like some weird rules according to some keywords in C++ for where the order where you put it. But moot has to be there. Okay. Adding move conveys the intent. Okay. We're allowed to change the value bound to x when moot is used, and ultimately deciding, okay, that's fine. Constants, like immutable variables, constants are values that are bound to a name and are not allowed to change, but there are a few differences between constants and variables. First, you aren't allowed to use moot with constants. Constants are just immutable by default. There Oh, aren't just immutable by default. They're always immutable. You declare a constant using const keyword instead of let. Okay. And type. Okay, and the type of value must be annotated. We'll cover types later, so don't worry. Okay, I'm not worried. Rusticeans. Like crustaceans. Okay, thank you, folks. Thank you, Hadenir and the line. Okay, and this is typical constant declaration, which is cool. Okay, now we can const ASDF. Do I like really have to specify the type? Let's see, const, and let's see if it also complains about the casing. Like, do all constants need to be in capital case? Is that like a language level requirement or just style? So let's do like you as a literal of a 32-bit literal. Does it really? Yeah, I really need to give it a type. Okay, that's fine, I guess. It's never used and should have been uppercase. Okay, so it is a warning, which means it's not a hard requirement, but it's good. I like it. Variables, bin variables generated one warning, and constant is never used, and I guess I can do this to get rid of that warning. Yeah, that's correct. Okay, so I know something. So this is fine. Then shadowing. Yeah, shadowing is what... but this is... Yeah, like... This is a different variable, right? Like, this is internal shadowing, like internal scope, and this is external scope. So here we are going to get... Oh, and here is using a different variable. Oh man, that's messy. Okay, let x equal 5. Let x equal x plus 1. But like these are like, this is like, what's it called? Like SSA, right? Like single statement assignment. Wow. Okay, this is messy, but it's not that bad. It's, yeah, it might get really messy if somebody moves the code around. Okay, inner, it's x. I need to remember that I can do this. This is cool. And outer is going to be outer another x. Yeah, so what do I expect here? I expect here to be, this is going to be 6. I expect here to be 6. Like, yeah, like I don't believe this is complicated. And here I expect to be 12. So let's see if I'm right. Yeah, 12, 6 as expected. All good. Yeah, I don't need this explanation, I guess. Okay. Other difference between mut and shadowing is because we're effectively creating a new variable. Yeah, well, that's obvious. That's okay. Okay, data types. Which tells Rust. Okay. Rust is a statically typed language. Yeah. Which I guess I can like check one thing, like let's do let x be the type of u32, and I'm going to assign this like a value which is u16. Is it going to complain? I'm pretty sure I checked it. Yeah, it's going to complain. I like it. I like it. Because there's like the integer promotion in C++ is like that's like it's like a few pages basically in the language standard, and they are not super obvious at the beginning, which is like I really like that. I really like that it complains about this. This is good. This is cool. And shadowing, you can change that variable type, Martin writes. Yeah, because like, yeah, shadowing is just creating a new variable. It's like same in C++, right? And in other languages. I wonder if there's like a way in Rust to, but I'm here, right? But I want to reach this variable? Is there a way to do it, or is it like basically the assumption that the moment I overshadow the variable is created? I think somebody on chat told me that, sorry, that the variable is destroyed. I think someone on the chat told me that's not the case, but the scope of this variable still would end here and not with the creation of this. I guess if I would grab a reference to this variable, I could check it, right? So if I do, I have no idea how references work, so please excuse my lack of knowledge in what I'm currently going to do. And then I want to do print ln and do ref and do a dereference on y. So X scope should still exist. That's my hypothesis, basically, is that X scope doesn't end when it's overshadowed. It's like it has a normal scope of from here to here, which means this should work. This should actually work. And it actually works. Okay, so my hypothesis is basically correct. That how it works, which is good. So yeah, it's not like you're changing the type when you're creating, and when you're overshadowing, you're just creating a new variable with the same name. Martin writes, there are no hidden casting in Rust. Good. Good. I'm happy to hear that. Okay, what's going on here? So we are doing parse and expect not a number. What does this expect here mean? Expect not a number. Okay, let's test that one. Let guess U32 B32 parse. Okay, what? I'm going to dissect this in a moment. None, Batman. Yeah, like the old JavaScript joke. Okay, and it complains that. Yeah, I'm not using it. It's fine. Okay, so what happens if I remove this? Oh, because it's a result. So if I have to do like, and it's a result, which means, oh, so I'm guessing expect is basically like if it crashes, it should die with this. It should die with this message. So let's try this. Let's do none and do like here ASDF. Is this, by the way, this is runtime or compilation time parsing? Okay, so it did panicked none. Okay, cool. Is this, yeah, is already my none, right? And main thread panicked, parse int error, which is fine, which I like. If I would do, okay, and I cannot do like unwrap because unwrap was for optional, right? It kinda worked, but it panicked. Okay, so I guess expect is kinda like, it's kinda like unwrap, but it allows us to specify another message to be used. Let me validate that. Rust unwrap versus expect, yeah. And there's also the question mark thingy, right? Expect does exactly the same thing, except it prints a message. Okay, cool. And a question mark was, what was the question mark? That was basically an unwrap. No, that was like pass an error and return from the function, something like that. What does it say? Yeah, I cannot, the function should, yeah, return. Okay, yeah. So this is return basically. Cool, so I think I need to make a note from that. Various stuff. Okay, basically for optional or result, well, I'm not sure about optional, but at least for result, the unwrap is the same as expect error message with the exception of the error message. Okay, and the ASDF means if the if ASDF returns result or option and current, why is it, yeah, function also does so, and then return and return from this function in case of an error passing the option further along. Okay, this is a really nice syntax sugar, I like it. Cool, let's go here. Okay, so this is fine. Now what I wanted to check is like, is this compilation time or is it, I don't know if it's, no, I know it's compilation time, right? Sorry, I know it's not compilation time. Let's do build. Yeah, it builds. It just doesn't run, so it isn't compilation time. What does it do? Like, how does it work? What can I do weird here? Let's see. Let's just show me guess if you could. Yes, exactly. I wonder how frequent this error is. Okay, 42. Now, so I can do, I guess, a lot of zeros here. Can I do a lot of spaces here? I cannot do spaces, apparently. Okay, can I do a minus here? No, because it's unsigned, right? But can I do an no, it panics in this case. Can I do a plus sign? I can do a plus sign. Can I do multiple plus signs? I cannot do multiple plus signs, that's good. I can do only one, I'm guessing. Can I do like plus, this will work. Can I do a space afterward? No, I cannot. Can I do E0 after it? No, I cannot. Can I overflow the value? Let's do this. No, it panics with positive overflow. Hey, that's a nice one. If you're wondering what C++ does, then just go to my blog. Like it depends on the library, of course, but and look for like scanf, I think. It's a really old article, but like various behaviors of scanf and so on. It's basically an article like on what's happening if you give a like too large value to an integer, to string to integer conversion function on like different libraries and so on and so forth. Sometimes it's pretty funny, so I'm just going to leave this with you. Yeah, and I guess like Rust is behaving really logically here, and I like how it's behaving. Let's go back here. Sorry, I was playing with this. Is there anything else? Yeah, there's another thing which I can check is like what digits does it support? Because it supports these like Euro-Arabic digits, which are actually what Hindi digits, I think, not really Arabic. There was like I've read there was some translation error, and these are attributed to be Arabic, but they were actually closer to Hindi or something. Anyway, well, European digits currently. But these are not the only digits out there, or rather Euro-Arabic digits. I guess that's what Wikipedia calls them. So Gunvale 42. Okay, Gunvale Unicode integers. Yeah, this is how you write integers. So if you go to this page, for example, this is like 42. Like this looks like an 89, but these are actually like Bengali and Oriya digits. So if we use like if we use here, yeah, because like these are Arabic digits, like they're like they aren't really too similar to these ones, right? Anyway, so let's grab like a Bengali digit and let's see what does Rust say for a Bengali 8. Well, 8, that's Bengali 4, of course. And it says invalid digit. Okay, so it doesn't support out of the box I wonder if I need to update this. I probably need to update this article. Oh, if you're wondering what article is this, let me give you a link as well. So, yeah. Okay. Now, what can I else check here? Martin writes, check UTF signs with digits. Like what do you mean by signs? Like let's change this to integer, by the way, 32. What does it do if it gets an empty string? It should error as well, right? And it does error with empty, which is fine. So let's do minus, just minus, and it says, yeah, that kinda is bad. -0 is 0. Let's do, instead of minus, this isn't a minus, this is a half pause or full pause. I don't know. I think it's half, because like that's a minus. This is yeah, I think that's a half pause. I have it on my keyboard because, you know, writing articles, you have to know which dash to use. Okay, it doesn't like it, which is good. I'm going to try with another one. Yeah, it doesn't like it. Can I do a couple of minuses? No, that's invalid digit, which is fine. Okay. Oh, you mean like double circled digit? Yeah, we can check that. I guess we can check this one. Thank you, Marcin. Yeah, it doesn't work either. We can also use like Unicode full width digits. Half width and full width. No, I want to have full width. This is, I think these are full width. Let's see. Yeah, these are full width because the font changed a little bit. Yeah, it doesn't work either. Unicode is fun. Like, yeah, ASCII wasn't as fun as Unicode is. You can see like that how these two 5s differ basically. The full width one and the half width, the normal width one. Okay, so actually the parser behaves really well. The typical issue with parsers, but I'm pretty sure they addressed it, is like it's going to be 2 to the power of 31, but with a minus, because this is like, it's a little bit of an annoying number to parse, but I'm pretty sure they got it right, because like this language exists for more than 1 month. Yeah, they got it right, which is fine. Okay. Cool. Actually cool. I like this parse. Okay, and this was totally a sidetrack because like I wasn't supposed to be doing this, I was supposed to be doing something else. So let's go back here to see if you don't add the type annotation in proceeding. Okay, if I don't add the type annotation, then it doesn't know what parse to call, right? Yeah, type annotation needed, because yeah, it has no idea what parse to call. Like, do I want to parse it to a float, or do I want to parse it? Is there like a, like, I don't know, is there like parse I32, for example? No. I32? No. Okay, so apparently it has to have this. How does that work? How does it? That's kind of weird. Okay. And I guess like, what's a proper type annotation? How do they write it? They write it, okay, colon here and then type. Okay, ooh, thank you chat. Chat, you are amazing. And there are like multiple people. Patix, Hadenir, Joe Biden, and Panbubr. I see what you did there. Okay, so I do this, parse, then a namespace, which is weird, I still don't understand this, and I do this. And this works. Cool, cool. Okay. I32, yeah. Okay. So if you want to add this, Rust will display an error. Okay, scalar types. A scalar type represents a single value. Rust has 4 primary scalar types: integers, floatings, booleans, and characters. No fixed points and no decimals. I'm guessing floating points are binary floating points, or does it have decimals? We'll see in a moment. Why do you need decimals? You need decimals because if you have a value like this, it's not representable in binary floats. I'm sorry, it's just not. Like, you can do the math, it's not representable. But therefore, like, it will be either a little bit below or a little bit above, kind of depending on how the like rounding rules work, and which ones are chosen. Yeah, but if you have decimal floating points, which are, by the way, part of the IEEE 754 standard from the new one, not the 85 one, but the one which was in like 2000 something, then their decimals are also defined there. Okay, integers, we have up to 128, and architecture native size, I'm guessing, is going to be just I size. I'm super curious about these types. These types are fun. I don't think I ever needed to use such a type, because it's pretty funny, like with types, right? It's like either 64 bits are enough, or 128 bits are going to be not enough for what you need, right? Like when you're doing, for example, modular arithmetic, like in RSA, then you need like way larger numbers, like I4096, for example. And so yeah, so it's like this is not enough, but it's pretty interesting that they added support to it. I don't hate it, honestly. Dimka writes, the weird syntax is called turbofish operator. You're joking. Is that a thing? Is that actually a thing? A turbofish operator? Turbofish operator. That is actually a thing. Oh wow. Turbofish operator. Okay. This has to be one of the better names I've heard for an operator. Turbofish operator, that's hilarious. It kind of reminds me of the name of like a tadpole operator, which is like this one, or this one, because it can go either way. And this is basically like increment by 1 or decrement by 1, and I don't remember which one is which. And there's a funny reason why it works, but never mind. Okay, so yeah, turbofish operator, apparently. Okay, Matrix writes, it works because there's a parse trait which is implemented for I32. Okay, that makes sense. This is why we learn Rust, to explore burrows and catch turbofishes. Absolutely, yes. Okay, each variant can be signed or unsigned. Okay, anything else is important here? Signed numbers are stored with to complement. This is the same like in C++. This is typical to complement. We don't need to care about that. You can write integer literals in any form shown in table. Okay, so yeah, I think I saw like in Python also the syntax, right? Like Python 3 something introduced it. 1, 2, 3. Yeah, it's the same in Python. Then we have hexadecimal, octal, same in Python, and binary, that's fine. And byte, this is U8 only. It's actually same as in Python, but not fully, right? Like in Python you can also do BA. And this is like actually a number. Who knew? But it's actually not. It's actually a bytes object. But if you use the operator on it, it will be casted into an integer. Or converted or whatever. Or read, rather read. I think casted is the proper word here. So how do you know which type of integer to use? This isn't a Rust problem, I guess. Integer overflow. Yeah, what happens if we overflow? Will occur. Okay, when compiling in debug mode, Rust includes checks for integer overflow. But with release, Rust does not include a check for integer overflow. Instead, it performs a two's complement wrapping. Is it guaranteed to perform a two's complement wrapping? Let's check, shall we? So, let's do a... I need a function for this, otherwise it will likely optimize it. F and if, and we take I32, wait, A, which is I32, and B, which is A42, and this thing returns, this is the syntax, right, for returning I32, surprise, surprise. And what I return is A by B. So now what I want to do is I want to create a new variable which is going to be called res and is going to be also I32. And I want it to be equal to, oh, I don't need to write it by the way because the function will know. And I want to pass to it the value which is the following. Where's my Python window? This value and -1. Okay, because this is well, this is typical, right? This is just a sign change on this value, but there are less positive values than there are negative values, and this will in C++ this will crash the app. This will actually crash the app due to not due to C++, but due to how x86 does divisions. So let's try this with cargo run, and it panics. Unused variable, yeah, it's unused. Let's do print ln res. Okay, and it panicked because it overflowed. And now let's do cargo run release. Is this how I do release? And it attempt to do. Did it actually do release? I'm not sure if it did release. How to run cargo and Rust in release build. Yeah, okay, it's good. So, but it attempted to divide with overflow. So it did still throw an exception. It didn't do a TOS complement on it, which is good, which I actually like. That's fine. But here what they are also saying is if I would have like, this is not how you make comments in this language. If I would have r equals to 255 and let's do u8 and let's do it mutable and let's increment r by 1. Is this how I increment? Can I increment it like this? And then I do like println r. Let's do this. No. Cargo run. It says panicked because there's an overflow, and if I do release, it doesn't. Okay, so there's it does like what they describe here is basically correct, but they apparently have an like they do still some checks in case they do a division. Because yeah, like people just don't get division right, so you can still likely, if you can pass these values to an application, you can still crash it. Which is a better outcome, in honesty. I would prefer for like, okay, it's an old discussion, okay, whether every overflow should be checked, but yeah, I would prefer it to be consistent between the bug build and release build. And also, is there a way basically to say what kind of, say that I actually want, maybe here, but I actually want a variable which is going to wrap. Oh, wrap in all modes, wrapping method, wrapping add. Do you have saturated? They have saturated. Ooh, I like this language a lot. Let's try saturating add R1. Oh, you're right. Yeah. Okay, let's do this. Wait, because I didn't do do I need to do, wait, what? Use of unstable. Why is it unstable? Why doesn't it, like Rust, have saturating addition in stable? Am I doing something wrong, folks? Oh, it's, you say I'm supposed to do, this is a method. Is it going to do in-place addition? That's weird. What's going to happen? Yeah, unused. Yeah. Exactly. So it's not an in-place add. I would have to just do this basically. Yeah, I think this is fine. Now div is never used. Yeah, I don't need it anymore. Let's just comment it out. And I get 20. Yeah, it saturates, but absolutely amazing. And then I can have what? I can have an overflow. Wait. And I can have a wrapping and a checked add. Yes, I like it. Wait. Option. Because it can crash. Okay. So here I do expect lol. Yeah, nice. Okay. You have actually saturated and checked adding and wrapping adding here. So I like it. I like that you have the option to actually say that, yeah, I would like to have saturated addition here or saturated multiplication. If you're wondering, like, if you're doing computer graphics, sometimes using saturated is better. It's just better for the math which you're doing. And checked is something like if you're calculating some sizes, you might want to use checked. And wrapping, there's a lot of crypto math where you would like to use wrapping. So it's really, really amazing that they actually have this in the core library. I'm really positively surprised by this language. What I'm a little bit less positively surprised is that they have inconsistent behavior by default. It's like it panics in the bug mode, but on release it doesn't. It's like I understand the purpose of it, but I would prefer it to be consistent. Like always panic or always wrap. But okay. Okay, then we have floating points. We have only 2 floating points, like 230, F32 and F64. IEEE 754. Binary ones. Yeah, which means they don't have decimals. I'm pretty sure there are libraries which support decimals. I think like the C language has in the standard decimals or something, which is kind of funny, but there's like some backstory to it. Okay, numeric operators, Boolean operators, true, false, lowercase, bool, lowercase. Character type. Character type is the most primitive alphabetic type. What are you? Char, literal single quotes. Okay. Character 4 bytes in size and represents. Okay, good choice. Good choice. It's a really good choice because if it would be like just 2 bytes, like then yeah, like you couldn't put emojis in there because like yeah. Or is it emoticons? Which ones are which? I always confuse them. Emoji, Wikipedia, not Emojipedia. Yeah, emoji. Okay, so this is emoji and the other. Yeah, so you cannot put emojis, and the other one is like the text ones or emoticons. Emoticons? How do you even say that? Anyway, so yeah, you couldn't, and due to choice of 4 bytes per character, you can. This is a good choice. Compound types. Okay, and then we have compound types. Can group multiple values into one type. And it has tuples and arrays, which are primitive compound types. Tuples. Oh, and it does the structuring as well. Or is it no? Is the definition of tuple? Is not the structuring. Okay, that's cool. Here's the structuring. Which is nice. With syntax though, like .0, .1, .2. Well, I guess it's an unnamed field, so yeah, okay. It's funny, pretty funny syntax, but yeah, I guess I can note that tuples have funny syntax. Tuples have funny syntax. Let's just use like x f64 u8 equals 500 6.4. It's kind of funny because Rust doesn't have casts, but here we have casts, right? Like yeah, like literals are not, it's not clear for a programmer what this literal is until they actually look at the type. So it does like a cast from, like, for example, 1, which is likely treated as like some kind of a larger literal, but is like then casted here. Okay, and then we do let sdf equal x dot to this. Okay, then we have the array type, which is which we played with already previously. And accessing it. Okay, invalid element array. Index. What does it do? Is it checked? Yeah, it's checked. It's actually checked. How do they, by the way, please enter index when they create a new string which is empty. Then do IO std in read line. You know what? I'm going to retype this example because why not? Because it's like actually might be worth knowing. So let's do use std IO. Okay, and we have what? Let a 1, 2, 3, 4, 5 print ln index, please. Let mutable index string new. Wow, this is a little bit chatty. Okay, it gets some read line mutable index. Okay, so here I'm taking a reference to it. Does that mean, is it the same as borrowing it? I don't know. That's what I want to figure out today. To read line. Wow, you need to it actually returns the result. That's not a bad choice. Yeah, like Rust really is into defensive programming, I would say. Index is index. Oh, okay. But I trim it, I parse it. Oh, okay. That's why we have the type specified here. And if it fails, well, I expect like not a number. There we go. Okay, cool. And here I do element a index. Okay, and I do print ln val at index is element. Cool. Go. Release. Oh, it crashes because I'm still playing. I'm still playing with this stuff here, so let me do this. Yep. Index, please. 1. Okay, -1. Invalid digit. No, 9. Out of bound. Okay, and I'm in release mode, and it's still doing bound checking, which is basically like .at in vectors in C++, which is good. Okay, cool. Hadn't you realized that borrowing is the Rust name for taking a reference? Shared borrow is immutable references, and exclusive borrow is mutable references. So, okay, is it the opposite? As in, like, is this, if I have mut here, with an reference, does that mean that I'm doing the exclusive borrow, right? And without it, it's going to be, this would be a shared borrow then. Am I getting this right? Okay, functions. I don't want to read about functions because I already saw a lot of that. Statements and expressions. Okay, I know what's a statement and what's an expression, even though in Rust it's a little bit more funny. Give more borrow checker comments. Oh, do I have what are there any funny comments? Control. One thing which I can check with comments is like, can I do like you know, Unicode emojis in comments? It should be fine, right? Yeah, it's fine. If expressions, okay, I played with them already. If in a let statement, yeah, I already saw that. Repetitions with loops, it's, yeah, it has a loop. Returning value, I'll play with loops later on. A loop is just an infinite loop, right, with breaks. So you don't have to do like in C++, like while 1 or like 4. I prefer like this infinite loop, but it surprises people a little bit. I remember back in the days, like when you were running Visual Studio Visual C++ compiler with all warnings, it would complain that you have a while loop with a constant value here. It would like complain, and if you had like warnings to errors, like warnings as errors, then you just like couldn't compile a code with an infinite loop, and that was ridiculous. They removed it later, thankfully. I should read about expressions. It's a unique approach, Jovan writes. Okay, let's go back to expressions. Is it Jovan or Jovan, by the way? Control, that's control flow. I just need expressions, comments. What was this? Functions. Where are expressions? Statements and expressions here. Expressions evaluate a resultant value. Okay. What's weird about expressions in Rust? Is this a question for this guy? Let's see. So what's weird with expressions in Rust? Horizontal C++ or Python? Or like JavaScript or whatever other language I know. Yeah, I know. Okay, let's allow it to generate, and let's read in the meantime. Function definitions are statements, yeah, of entire proceeding. Yeah, if you're wondering, like normally in a programming language, right, like this whole thing, like one line basically ending with a semicolon is called a statement. Or like a whole function might be called a statement as well. Like until here, right? While like a thing which has a value, which is evaluated to a value, is called an expression. So like this might be an expression, while this might be a statement, right? And a statement can have multiple expressions as well. Like here you might have like index might be one expression, then this index, whatever index results together, returns together with this might be another expression. Whatever all of these returns is another expression, and so on, and this is the last one basically. And then you have basically an assignment statement here, right? Or like rather an initialization statement. Definition, I guess you can call it a definition. Okay, so what's weird? This is an error, yeah, because it's a statement. Does not return a value, so yeah, that makes sense. Expression evaluate to a value and make up most. It's like in every programming language. Calling a function is an expression, yeah. Calling. I wonder, like, if it's like one weird thing in C++, for example, is if you have a function and you have another function and one more function and yet another function, then it's obvious, but these functions need to be called and evaluated, right, as an expression, because this is an expression. So, and these are like free expressions here. So all free expressions must be evaluated before the function is going to actually be called, because, well, it needs to know what parameters are going to be put, like, to get to operate on them. But in C++, it's unclear in what order are these functions going to be called, and this order is actually not specified. As in, like, it can be random. You should not assume that it's going to be first A, then B, and then C. It can be like CBA. It could be ABC. It could be ACB. It could be and so on and so forth. Right? There are like a couple of combinations here. So that's pretty funny, and like you can sometimes, rarely, when you're relying on the order of operators, and the stuff is running on your computer, it's fine, right? And when you like upgrade the compiler or like send it to production, and then they compile it with a different compiler or with different optimization modes, and suddenly the order changes, and you're like, yeah, why is this code not working? So most modern languages actually define the order from left to right, obviously, right? And also in C++, back in the days, but I think they might have changed it, is like the same was true for this, basically. Like, it was also unclear which, like, would this be evaluated first, or maybe this thing would be evaluated first, right? It was unclear because addition is like, you can change the order. But I'm guessing, like, currently it's left to right in C++. I'm pretty sure that the compilers just enforce it. So yeah. And Rust, I'm pretty sure, is going to be left to right, because this language is like really about like defensive coding and secure coding. Oh, this is fun. But this isn't unusual either. I think I saw this kind of code in some extension to C, like years ago. Okay. Matrix89 writes that regarding comments, doc comments can have tested code snippets, which is amazing. Really? Now that's a nice feature. Okay, even writes that it's the no return thing at the end. Yeah, this took me by surprise when I first thought it. I didn't know this is a return value, actually. Like, yeah, this is, if it's missing a semicolon, it's a return statement. Yeah, okay. I mean, it's kind of like an arrow function in JavaScript, which I guess like also doesn't have a return statement, but okay, yeah. So I saw like something like this in some other language. I'm pretty sure I saw like, but you can actually, or maybe that was even in C++. I don't know. I don't remember, honestly. Like, basically, you can give it a block of code to evaluate, and after evaluating, I know in C++ core guidelines, there's like, because in C++ core guidelines, they push really hard to use immutable values, variables like in Rust, right? And what they said is like, if you have something like this, you need to do some more advanced calculations to calculate that value, which is at the end of the day going to be immutable because you don't want to change it. But what they said is basically make a lambda function and call it, which will be inlined anyway, so that's fine. But yeah, this is what this reminded me of. Okay, thing is, function body is expression as well. This is why no return works. That makes a lot of sense. Yeah, but this whole thing is actually an expression. I like it. This is useful. And it allows like this to be immutable. You don't have to make it mutable, then do the calculations. Wait, somebody also said something super important. Plasma writes that in Rust the order is always left to right when ambiguous. It's defined. Yep, I expect Rust to be fully defined, basically. Because like one of the major issues with C++ was that it was not defined. It's not fully defined. It's like, it's both a good thing and a bad thing in case of C++. Why? Because like, for example, in this code, Rust has to generate additional statements to check if like these weird values, which I gave here, right, aren't passed to the function. but it can throw an exception. And in C++, the compiler doesn't have to generate that additional code, because the compiler is like, yeah, like in most cases this behaves like this, but if you have enter like an undefined state basically, then it's basically whatever is going to by accident almost happen. It's kind of usually passed to what the architecture will do, like the CPU will do. But yeah, but thanks to that, like the C++ doesn't have to make sure that this division of weird numbers always throws an exception or always returns like this value, for example. In case it can just not care about it at all and like leave it to the programmer to handle it if it's important. And therefore it doesn't have to generate additional code. Therefore C++ is going to be at the end of the day always one of the fastest languages out there, because it just doesn't have to generate a lot of safety checks, which other more secure aware languages like Rust apparently have to. Cool. Yon writes that while loop you can also add value on break. That's amazing. Okay, so Yvan writes you can do let val equal loop break value. One question I always have in terms of languages: does it have nested breakouts? As in, like, if you have like one loop here, right, and then you have another loop here, then can I break out both loops? Like do like break .2, for example, to break out of both loops. And there are like languages which allow that. There are like some languages which would like allow you to name a loop. Like, for example, this one would be called ASDF, and if you do break ASDF, it would just break out of the external loop. It has it on the next page. Okay. So let's look in the next page. So let's look at break. Break. You can place a break. Okay, break counter. So this is breaking with a return value. Ooh, perfect. Nice. Okay. Honestly, I sometimes need this because, like, if you don't have this feature and you cannot break out of like a named loop, like, you know, just like go 2 stories up, you need to create additional flag variables which you need to check. And having the ability to break out 2 loops is useful. It's like something, I'm not going to say I'm going to use this every week, but every month, yeah, it's likely. Really nice, really nice. So apparently it's not loop here, it's a single quote loop. Single quotes are also used for, what were they used for? And the order is by very different. For lifetime, right? Okay. Okay, so you know what? I'm going to copy this to my random notes. Where we go? Loops are expressions. Or rather, well, are, yeah. I wonder where are an expression or can be an expression. And do this maybe. Here, loops can be named. Yeah, I like this feature. Like, there's on my blog post a post from like 10 years ago about features which I'm missing in C and C++, I think, and named loops were one of the features which I was missing. Okay, let's just format this a little bit. Fira code. Okay, Sticks writes that, yeah, they are expressions. Like, every block is an expression, which means you can do really fun stuff in Rust. Cool. Oh, I am so going to make some like fun Rust source code level reversing challenges. Because reversing when you have a binary is one thing, but you can also make challenges where you have just have like the source code, right? Instead of the compiled version, and it can be obfuscated, and you can do magical stuff with it. Especially if you have like some kind of templates or some kind of like weird type processing, like TypeScript. Like look for TypeScript or C++ template challenges or TypeScript type reverse engineering challenges. It's like, yeah, it's like your brain will melt, but in a good way. Yeah, you heard it here first, but there are good ways to melt your brain. YouTube, don't ban me. Maybe I should have a disclaimer like, hey, this is like a satirical programming live stream. Okay, so I'm guessing you can do like the same with other stuff, with like force and yeah. Okay, cool. Understanding ownership. This is like was supposed to be the main topic of today's stream. Ownership in Rust is Rust's most unique feature and has deep implications for the rest of the language. It enables Rust to make memory-safe guarantees without needing a garbage collector, so it's important to understand how ownership works. In this chapter, we'll talk about ownership as well as several related features: borrowing, slices. Oh yeah, because you can do slices in two ways, right? You can do a slice. I think we already touched on this because you can do slices as a memory view on some other existing object, or you can make a slice as a copy. And in Java, if I remember correctly, there was like a problem that if you had like a 1 GB buffer and you took like a 1 byte slice of it, then it actually increased the reference counter on the gigabyte buffer. And even though that object could went out of scope, right? You don't no longer need it. The garbage collector couldn't garbage collect it, in the past at least, maybe now it's better, because there was still a reference to 1 byte, like a view of a slice of 1 byte. On the flip side, in Python, every slice is a copy, which is like has other issues, right? If you are basically just slicing a string in a loop 1 byte at a time, this is a lot of copies of memory. So like you can go either way, and let's see how Rust goes. But I think we already discussed this, and I think it was about the memory views at the end of the day. And how Rust lays data out in memory. Perfect. Yes, please. What is ownership? Ownership is a set of rules that govern how a Rust program manages memory. All programs have to manage the way they use a computer's memory while running it. Some languages have garbage collection that regularly looks for no longer used memory as the program runs. In other languages, the programmer must explicitly allocate and free the memory. Rust uses a third approach. Memory is managed through a system of ownership with a set of rules that the compiler checks. If any of the rules are violated, the program won't compile. None of the features of ownership will slow down your program while it's running. So it's compiler time checked, but we already looked in last live stream on runtime borrow checking, which I know already exists. Because ownership is a new concept for many programmers, it does take some time to get used to. Okay, it's not a new concept for me, but I don't understand how it works in Rust. The good news is, or rather, I don't know what tools you should use here. The good news is that the more experienced you become with Rust and the rules of ownership system, the easier you'll find it to naturally develop code that is safe and efficient. Keep at it. Also, if you switch back to C++, your code will be way better. Basically, because you will understand this model of ownership and you can use it in C++. Yeah, you have to use you don't have a borrow checker, but if you code using the same rules, your code will be just better, which is good thing to learn other languages as well. When you understand ownership, you'll have a solid foundation for understanding the features that make Rust unique. In this chapter, you'll learn ownership by working through some examples that focus on a very common structure, strings. Nice. I wonder what kind of structures would be good for experimentation. Apparently strings. The stack and the heap. Okay, do I need to read about stack and heap? I don't think I need to read about stack and heap unless there's something really specific to Rust here. Okay. No, there's like nothing which is Rust specific here. Once you understand ownership, you won't need to think about the stack and the heap very often. But knowing that the main purpose of ownership is to manage heap data can help explain why it works the way it does. I guess this is the only part which is important. Okay, ownership rules. First, let's take a look at the ownership rules. Okay, so this is like rules, we have rules, but we have 5 rules and they have 3 rules. Okay. Wondering to rule them all? Wrong story, I guess. First, let's take a look at ownership rules. Keep these rules in mind as we work through the examples that illustrate them. Each value in Rust has an owner. There can only be one owner at a time. There can only be one owner at a time. This is like phrased in a way which, what was it, like Highlander, right? The movie. There can be only one. When the owner goes out of scope, the value will be dropped. Okay, which kind of means that like if you have, like in C and C++, right? Like you have references to it, and then you don't want the owner to go out of scope. And I'm guessing Rust checks this on compilation time. So there will be, I cannot write code basically in Rust which will without using like unsafe, where this would happen. That's the idea here. Okay, so these are additional rules in that case. Each value, not a variable, each value must have an owner. There can be only one owner at a time. This was also like there can be only one, but was a cheat code for Warcraft 1, the RTS, I think, for immortality. Like your units were invulnerable, I think. When the owner goes out of scope, value is dead. Yeah. Yes, okay. Dropped. Freed, I'm guessing. Cool. Variable scope. I think we already looked at the scope, right? Now that we're past syntax, we won't include main, okay, because you're, okay. So let's create a new program, I guess, so we can kind of play with them. And we are here. Okay, cargo new ownership 1. Ownership 1 source sub main. There we go. Okay, so we create what? A variable. And the variable is not valid before being initialized and is valid. Yeah, we played with this today already. In other words, there are 2 important points here in time: when it comes into scope, when it's created, and when it goes out of scope. Same in other programming languages. Except for Python, which is weird, right? And JavaScript, which is weird. Like in Python, the scopes are different, right? Because the variable is scoped to a function, to not a block of code, but to function. But in JavaScript, a variable which is initialized with var is really weirdly scoped. It's like if you make a, I guess like I can just do JS. Yeah, it's like if you have a function in JavaScript and you do, like if you do let a equals 5, for example, and you do console log a, and let's call ASDF, and I think I have Node installed. Node ASDF.js. Yeah, it says I cannot access A before initialization, but if you do a var, it behaves weirdly because it's undefined. Like A already exists here. A is basically, this is the moment A is created if you are using var instead of let, but it's undefined. But it exists, right? Undefined. Yeah. So yeah, like that's weird. That's a really weird scoping in JavaScript. But JavaScript is weird. So yeah. It's hoisting. It is hoisting, but it's still weird. But yeah, like JavaScript was like kind of like PHP, right? Like these languages were created because they were needed and they were really organic. Like when they grew, they were like growing really organically. I've been coding in JavaScript from like 98. I think 98, 25 years. So when I started coding in JavaScript, it was when Internet Explorer 3 was almost everywhere, and Internet Explorer 4 was just coming out with DHTML, which was basically dynamic HTML, allowing you to do some fancy animations in JavaScript, and with like some fancy effects in HTML attributes. But everything was thrown away later on. But that was pretty fun. So yeah, like the evolution of JavaScript is absolutely interesting. It's like super interesting. But I really like the language, but it's not a good language. I know I keep repeating that, and I know it kind of sounds funny, but like, oh, Gunvale, you spend so much time coding in languages which you think are bad. Well, yeah, because I'm at the end of the day a hacker, and I look for badness, right? So yeah, that's how it is. Okay, so to illustrate the rules of ownership, we need a data type that is more complex than both. We cover, okay, yeah, the types covered previously are of known size and can be stored on the stack, top of the stack. Yeah, okay, this is cool. And can be quickly and trivially copied to make a new independent instance in another part of the code. This is exactly what I was looking for. It's like that plain old data is plain old data at the end of the day in Rust as well. But we want to look at data that is stored on the heap and explore how Rust knows when to clean up that data. And the string type is a great example. Perfect, let's go. We concentrate on the parts of string that relate to ownership. These aspects also apply to other complex data types, whether they are provided by the standard library or created by you. We'll discuss string in more depth in chapter 8. We've already seen string literals where a string value is hard-coded into our program. The string literals are convenient, but they aren't suitable for every situation in which we may want to use text. Well, obviously, yeah. Unless you do fancy. Sorry, by fancy I mean hackish, which you shouldn't. I mean, they are in memory. You can likely find where they are in memory and just, change the memory permissions to be writable and play a little bit with that. But yeah, let's not go there. Did you know that if you try hard enough, strings in Python are mutable as well? And quite stably mutable. Yeah, if you're curious, you can look at my KrzaQ, but I think it's still like, it's still Python 2 KrzaQ. Oh, and I actually like also had a live stream about it. Like this one, basically. It works both on Windows and on Linux, but I think it's still Python 2 because it's 2016. But I've abused strings really hard there in Python. That was pretty fun though. That's a hard challenge though. And yeah, but if you're curious. Anyway, digression. Okay, yeah, strings convenient, yeah. One reason is that they are immutable. Another is that, like in Python, another is that, and it's kind of an NC and C++, I think it's like, I think by default they are immutable, but its implementation defined whether they are put in memory, which is read-only. There are some other, like, there are some interesting rules related to string literals, basically. It's like, if you have like two literals, hello, right? Is that, should the compiler create two different literals, hello, or should it just stick to one and like always refer to it? Which means that if you like do if hello equals hello in C or C++ with string literals, that might or might not be equal. And it's like implementation defined, I think, at the end. There are like also other things like a literal might not even be put in memory. It might be just put in code as like immediate values. So yeah, it's interesting. It's like interesting if you're into like deep into programming languages, I guess. Okay, another is that that not every string value can be known when we write our code. Yeah, come on. So Rust has a type string. This type manages data allocated on heap, and as such is able to store an amount of text that is unknown. Yeah, like same like C++ std string, right? You can create a string from string literal using, okay, so we are doing, but we are doing something else in a moment. Yeah, that's a namespace. We'll discuss the syntax later. This kind of string can be mutated. Yeah, mute as string from hello. From hello, interesting. I'll write because it doesn't have constructors. Never mind. World. And I can push this at the end, and then I can print ln. Hey, why are you? Can't I do this? I want to check if I can do this. Or does it only work for oh hi OBS? I guess I should be doing this. This should be a little bit faster. Yeah, sorry, give me a sec. Okay. Sorry, back, cargo build, cargo run. Okay, so I can do it. So apparently they didn't just update it, or I'm abusing some syntax, and this will be... Okay, the difference is how these deal with memory. I know how a string works, but let's go through it. Memory and allocation in like when we were hacking satellites, I was reverse engineering geofencing code, and I also looked at string implementation there. Anyway, memory and allocation. In the case of string literal, we know the content of compilation time, so hard coded. But okay, is there anything unusual here apart from like string stores data on heap, and it's just like basically a thin shell which is pointing to the heap memory and saying how long is the string and what capacity has the allocated memory likely. This is usually how strings work. And also a string can have an internal buffer for like small strings which could be kept on the stack or whatever. With the string type, okay, the memory must be requested from memory allocator at the runtime. We need a way to returning this memory to the allocator when we're done. The first part is done by us from. Okay, so this is like when we are building the string from the literal. However, the second part is different. In languages with garbage collection, the GC keeps track and cleans up memory but isn't being used anymore, and we don't need to think about it. Otherwise, we have to do it ourselves. Yeah, doing this correctly has historically been a difficult programming problem, absolutely agreed. If we forget, we'll waste memory. If we do it too early, we'll have an invalid address, and that's a security issue usually. If we do it twice, that's a bug too. Double freeze, absolutely. We need to pair exactly one allocate with exactly one free. Rust takes a different path. the memory is automatically returned once the variable, but once it goes out of scope. So here's a version of our scope. Okay, so here the stuff, and this is no longer valid. Absolutely. Okay. Six rise, but that's where string compare was born. Yeah, I guess like that's true to some extent. It's a like that's back to comparing strings and see which that catches people off guard. Like people just do, you know, string equals string, and they get actually pointer comparison and not string comparison, which catches people off guard. That's a weird thing and see. I came to see from after programming already in like a couple of basics, Turbo Pascal, and I think something else, and yeah, and I was caught off guard totally by it. Anyway, so what do we have here? There is a natural point at which we can return memory. Okay, S goes out of scope. Okay, so S is the owner, and yeah, the moment it goes out of scope, that's fine. Rust calls a special function for us. This function is called drop. Oh, does that mean I can just like, oh, it's a trait. Oh, which means I can define the destructor. That's cool. And let's define the destructor. How do I define the destructor? I want to do it. Cool. Drop. Okay, so what I have to do, like struct something. I guess the struct can be. I don't remember how do you do a struct. ASDF. Can I make an empty struct by the way in Rust? And can I implement? And I need to do, what was it, like this? And oh no, because I want to implement it by myself. So do a drop for ASDF. And what? How do I do it? You cannot call drop yourself. Okay. Oh, here examples. Perfect. Struct has drop for 444 ASDF. Okay, function does drop. Drop mode self println dropping stuff. Cool. And then I just do here. Let's do let. I need a constructor for this. No, I don't need, right? I can just do ASDF equals. No, I can just do like ASDF like this, and this should be fine. I have no idea what I'm doing, but it works. Hey, that's awesome. That's cool. That's good to know. I was wondering about it. Let's make a note out of this. Okay. So various stuff. There actually are destructors. Yay. Oh, let's just do this. I wonder how can I copy paste this without like in the same paragraph without changing paragraphs. Yeah, sometimes like languages are really strict about not having destructors, and that's a little bit annoying. Cool. No, I'm really enjoying Rust, honestly. So let's go back. That was a digression. Okay, and where the author of string can put code to return the memory. Rust calls drop automatically. By the way, how's the quality? Hey, the quality is okay, and we are already 2 hours into the stream, which is over 100 minutes. So maybe YouTube fixed the bug, which is cool. That's good. Bro, like if you weren't here, I had to restart the stream from time to time, basically to like every 100 minutes because the quality suddenly like dropped. Pun intended. Okay. In C++, the allocating is called ri. Yeah, drop function will be, yeah, cool. It's similar to like, I guess like exit in Python's ri. Python uses with statement for that. The pattern has a profound impact on the way Rust code is written. It may seem simple right now, but the behavior of code can be unexpected in more complicated situations when we want to have multiple variables use the data we've allocated on the heap. Let's explore some of these situations. Let's go. Okay, variables and data interacting with move. Multiple variables can interact with the same data. Oh, this is what I was waiting for, honestly. Because I still don't understand how do you, how do you copy stuff? I think like I'm starting to get that everything is a move in Rust, but I don't know how you copy stuff. So multiple variables can interact with the same data in different ways in Rust. Let's look at an example using, so I see in the chat that folks are worried about 2-hour mark. Don't worry about 2-hour mark, it should be fine. The 2-hour mark has a different role on YouTube. It's basically, or rather it had in the past, I'm not sure about now, is that if you do a live stream, then after the live stream ends, only the last 2 hours of the recording are available until the video is fully processed. And then when it's fully processed, everything appears. So there is like a window of usually 4, 5, 6 hours before YouTube actually makes the whole live stream recording available. Okay, so multiple variables can interact with the same data in different ways in Rust. Let's look at an example using integers. Okay, x equals 5, y equals x, assigning the integer value of variable x to y. And this isn't a move, right? You can probably guess what this is doing. Bind the value 5 to x, then make a copy exactly of value x and bind it to y. We now have two variables, x and y, both equal to 5. This is indeed what is happening because the integers are simple values, plain old data, as the term in C++ went, with a known fixed size, and these 5 values are pushed onto the stack. Now, let's look at the string. So we have a string and we do this. Sorry, give me 1 moment. I'll be right back. Okay, back. So yeah, strings. This looks very similar. So we might assume that the way it works would be the same. That is that the second line would make a copy of value as 1 and bind it to 2 as 2. But this isn't quite what happens. Take a look at figure 4.1 to see what's happening. Okay. It's happening to string under the covers. A string is made up of 3 parts, shown on the left. Yeah, pointer, length, and capacity. A pointer to the memory that holds the content of a string, a length, and a capacity. The group, which means that they are not using any optimizations for short strings, which makes a lot of sense. This group of data is stored on the stack. Well, in case of this variable, let's call it is stored on the stack. On the right is the memory on the heap, which holds the value. Yeah, typical string. The length is how much memory, yeah, we know, and the capacity is the allocated memory. Okay. When we assign as1 to as2, the string data is copied, meaning that we copy the pointer, the length, and the capacity. We do not copy the data on the heap. So we get this. This is okay. I mean, this makes a lot of sense, of course, but it's like what would happen in C, not what would happen in C++, because in C++ you have copy constructors, right? Or like assignment operators to handle these cases. But in Rust, so Rust is a little bit more like C in this case. That's good to know. That's a valuable information. The representation does not look like figure 4.3, which is yeah, what we would expect by a copy. Yeah. Earlier we said that when a variable goes out of scope, Rust automatically calls drop function and cleans up the heap memory for that variable, but figure 4.2 shows both data pointing at the same location. The problem is when S2 and S1 go out of scope, they will both try to free the same memory. This is known as double free error and is one of the memory safety bugs we mentioned previously. Freeing memory twice can lead to memory corruption, which can potentially lead to security vulnerabilities. Absolutely correct. It was like back in the days, but there was like basically some confusion about double freeze because it was like believed to be non-exploitable, and then someone came and like exploited it, and yeah, and then it was like, okay, it's actually a security issue. Fun times. That was years ago though. To ensure memory safety after the line, this one Rust considers S1 as no longer valid. Ooh. Therefore, Rust does not need to free anything when S1 goes out of scope. Check out what happens when you... Okay, let's do this. So we have what? Let's just do this. Let S1 equal to string from hello. Let S2 equal to S1. And then print ln and do and S1. Okay, what will happen? I don't know. Okay, so let's read this. Unused variable. So S2 is unused, that's fine. Borrow of moved value S1. Moved occurred here. Okay, so for plain old data, this is a copy operator. For is it true for I need to like okay I need to figure out the details later. For complex data, this is a move operator. Okay, so value borrowed here after move. Oh, that explains a lot why my linked list didn't work. Yeah, value borrowed here after move. So which means that here I implicitly used like this macro, I guess, is using a reference at this point. That makes a lot of sense. Cool. You get an error like this, and I get an error like this. Absolutely. If you heard of the terms shallow copy and deep copy while working with other languages, the concept of copying the pointer on length and capacity without copying the data should probably sound like, yeah, that's a shallow copy. Okay. But because Rust also invalidates the first variable instead of being a shallow copy, it's known as a move. Okay. In this example, we would say that S1 was moved to S2, but it's more than the C++ move, which I described at the beginning, because in C++ a move does not invalidate an object. It does not even destroy an object. It's just like moves away the heavy part, as defined by the programmer. So this kind of moving is highly interesting. Let's make a note. Okay, borrow rules. This is heading number 2, and let's like details maybe. Okay, let's move this out a bit here, and I guess like I could make this, and let's rewrite this example again because it makes a lot of sense. So we have let S1 string from hello. Yeah, as I said at the beginning of the series, basically I will try to type in as much as possible and copy as little as possible, because that's how you get muscle memory for a programming language. World. Okay, and let's do another one here. Let A equals 5, let B equals A. POD, plane of data, so this is a copy. Complex object, so this is a move. And I probably should change the font to be a little bit, I can do it a little bit smaller, okay. This is a move, and then what I want to add here is that a move in Rust also destroys invalidates the source variable. Okay, I think this is true enough. Am I open to mentoring people? At this point, it's a good question. I usually mentor people, and I have like a couple of people I'm mentoring right now, but given the amount of time I currently have due to creating, you know, I've created a company, and it's just like initial steps of like growing and still being set up and so on. It's I have literally zero time. It's like I'm pretty surprised that I actually find time to learn Rust, but I do need to learn Rust. I do want to learn Rust. So yeah, so which kind of leads me to saying, but yeah, try in some time, because like currently I honestly don't have the capacity, the mental capacity and the time to mentor another person. I'm sorry, but usually I do. Yeah. And folks, like I know there are like a lot of smart people on watching this live stream, so I do encourage you to take mentees and to mentor people. It's like, it's not the same as teaching somebody. It's not the same as like you know, being a tutor. Because the difference is that a tutor is supposed to, or a teacher is supposed to actually like give detailed information and train the person, while a mentor is more about the general direction, and it's a good thing to have a mentor. So if you're you know a little bit further in your career, or at least in your knowledge and skills, then absolutely help others, and like I encourage you to grab a couple of people to mentor. Okay, Marcin writes that for example, it's not about complex object, but copy clone traits. Ooh. Technically, thanks Marcin. This isn't about POD complex object. It's about whether something has a copy clone traits. Has copy clone traits. Traits, yeah, this is how we write traits. And this sounds super important, which kind of means that I can create my own type where this wouldn't be a move, and the object would still exist. Cool. That's really valuable. Thank you, Marcin. Okay, so let's continue. That solves our problem. With only S2 valid when it goes out of scope, it alone will free the memory, and we're done. In addition, there's a design choice that's implied by this. Rust will never automatically create deep copies of your data. No deep copies. Therefore, any automatic copying can be assumed to be inexpensive in terms of runtime's performances. That's interesting. You know what? I'm going to actually copy this quote. Yeah, another thing, like mentoring is one thing, but another thing which I really encourage people to do is to, like, especially if you're like at the, no, that's true for everyone. Actually, what I'm going to say is like, learning alone is fun, but learning with another person or within like a computer club or like a team is works better for some people. Because like if you find like a rival, like somebody who is like almost the same level as you are, or like a little bit a step further, and they become your friendly rival basically, so you try to outpace them, they try to outpace you, that's like super motivating to, like, you learn a lot in these circumstances if you are a little bit competitive. But yeah, I've had that happen to me when learning programming, and like the boost of skill level at that point was just like, it was like amazing, right? So because of a motivation, basically. And if you have a team of people, like, you know, just working towards common goal, be it just like, I don't know, just chatting about computers or writing some games or like some other projects, it's also way more motivating, especially if you have a good, like, the animation of the whole team is pretty good. Actually things is happening, that's really motivating as well. And I've been in this or that team related to computers from at least high school. And currently I'm also in like CTF teams, right? That's just like an extension of what we are doing, basically ethical hacking on competitions, like, but that's the extension of basically a computer club, which might be a little bit wider or focusing on a different thing. So yeah, like think about it this way: if you're still learning, and even if you're not still learning, you're like at basically any point in your career, think if you really need to look at this alone, or maybe it would be beneficial for you to find other people in similar situation and do something with them. Of course, like, yeah, for each their own, right? So not everybody likes interacting with other people. There are like some people who do prefer that, just wanted to get it out there, because what I also observed is that while on the CTF scene, bunching up, like grouping up in teams is super popular, that stopped being popular in programming for whatever reasons. It was pretty popular like back in the days, and now it's like, yeah. Cool. Okay. So variables and data interactive with clone. Oh, I guess we are getting to clone. Partialize. Agree. I'm learning Rust for the last 2 days. For the last few days. Today is much better. Yeah, learning with somebody is fun. It's like, I like learning actually on live streams, because it first is like focus time. I can focus only on this. And second of all, there are a lot of amazing people in the chat. Cool. Variables and data interacting with clone. If we do want to deeply copy the heap data of the string, not just the stack data, we can use a common method called clone. We'll discuss the method syntax in chapter 5, but because methods are a common feature in many programming languages, you've probably seen them before. Here's an example of clone method in action. So as one clone. Okay, I can do this apparently. Okay, so let's just copy this because it's faster than changing the font. So I'm guessing like the function is always called clone. Clone trait implementation, maybe? I'm guessing, and now like now both are valid. Yep. Cool. This works just fine and explicitly produces the behavior shown in figure 4.3, where the heap data does get copied. When you see a call to clone, you know that some arbitrary code is being executed. That code can be expensive. It's a visual indicator that something different is going on. Okay, so, but okay, so what's the copy trait? Okay, I guess I'll get to it later, but yeah, okay, I'll get to it later. Because this was clone. Okay, now we have copy. Stack only data copy. There's another wrinkle that we haven't talked about. This code using integers works and is valid. But this code seems to contradict what we just learned. Yeah, kinda, yeah. The reason is that types such as integers that have a known size at compile time are stored entirely on the stack. So copies of the actual value are quick to make. That means that there is no reason we would want to prevent x from being valid after we create the variable y. In other words, there is no difference between deep and shallow copying here, so calling clone wouldn't do anything different from usual shallow copying. Okay, that makes sense. Rust has a special annotation called copy trait that we can place on types that are stored on the stack, such as integers. If a type implements the copy trait, I think I'm out of water. I thankfully have more water. Okay, Rust has a special annotation called the copy trait that we can place on type that are stored on the stack. As integers are, if a type implements the copy trait, variables that use it do not move but rather are trivially copied, making them still valid after assignment to another variable. Rust won't let us annotate the type with copy if the type or any of its part has implemented the drop trait. Okay. If the type needs something special to happen when the value goes out of scope and we add the copy annotation to the type, we'll get compilation time error. Okay, interesting. Let's add it to values. You can either have the copy trait or the drop trait, not both. Okay. So what types implement the copy trait? You can check the documentation for the given type to be sure, but as a general rule, any group of similar scalar values can implement copy, and nothing that requires allocation or is some form of resource that can implement copy. And nothing that requires allocation or is some form of resource can implement copy. Okay, here are some of the types that implement copy: integers, booleans, floating points, character types, and tuples if all types contain copy. Okay, so okay, POD. Let's just write here. Okay, you know what? I'm going to actually write here. It's about to... Okay, so I'm going to go into details here. What this means is that POD type can and will have implemented the copy trait. Tuples are considered POD to have a copy trait if and only if they consist of PODs. Okay, anything else? And I guess a structure, an object can implement copy trait if it's made up only of PODs. Okay, I think that makes a lot of sense. Does that mean that an array has a copy trait as well? Because an array of integers could be considered... I wonder. I guess we'll get to it, because arrays are usually like mushrooms, not fully animals, not fully plants. Okay. Ownership and functions. I guess I'm going to go to the end of this chapter, and then I'm going to take to call it a day, because it's already 2.5 hours. I might continue tomorrow. I'll likely continue tomorrow, actually. Ownership and functions. The mechanics of passing a value to a function are similar to those when assigning a value. Okay. Passing a variable to a function will move or copy, just as assignment does. Okay, that makes a lot of sense. So here, because we are copying it, but not taking reference, then we are, but it is not a POD, therefore it doesn't have a copy, therefore it's a move. Okay. And here's makes a copy X, because X, this is POD, so okay, well that makes a lot of sense. If we try to use S after calling take ownership, Rust would complain. Ooh, that is interesting. Okay, okay, that is interesting. Note. Let's do this. This move copy stuff is true for any type of assignment, including passing as function parameters. Sorry, I always confuse these. Are these like function parameters or are these function arguments? Passing a variable to a function. Okay, okay. I'm going to say parameters. So let's type in an example here, I guess. Let's take this like fn take ownership string, and I guess it's just like can be like this string, and like do nothing, and then when I like call it takes owner, let's do let s1 string from sdf take ownership s1, yeah. This does a move. Okay, that's good to know. Okay, return values and scope. Returning values can also transfer ownership, I guess. So gives ownership, takes and gives back. Okay. So this returns. Okay. Oh, nice. Okay, got it. So let's do another example here then. Fn gives ownership. And we return a string. And we just do like string from SDF. And then we do let s1 equal gives ownership. Okay, cool. Not cool, now cool. The ownership of a variable follows the same pattern every time. Assigning a value to another variable removes it. When a variable that includes data on the heap goes out of scope, the value will be cleaned up by drop unless ownership of the data has been moved to another variable. While this works, taking ownership and returning ownership with every function is a bit tedious. What if we want to let a function use a value but not take ownership? It's quite annoying, yeah, which is basically where we are going with, okay. Yeah. Okay. Okay, luckily references. So the next one is references and borrowing, and this is where I'm going to continue next time. I'm not going to watch anything yet on the side, I think. So let's just do this. Continue from here. So yeah, so I'm just going to like continue with this next time. There are a couple of questions which I still need to answer, and let's note them here. Is basically, so what's this as ref thingy, which I saw, and the answer is yeah, like wouldn't you want to know? Cool. So am I closer to implementing a linked list myself? Well, closer every day, right? But no. But no, I might be closer to implementing a single linked list. I think I might be closer to that. Not yet, because I still need to learn a little bit about and figure out what was this asref thingy. But I think I'm closer to that, because I learned a couple of things, a couple of things clicked, a couple of things I did learn but didn't click yet. And so we'll see. Can I provide a link to the notes? I guess I can provide a link to the notes, why not? Share, restricted, anyone with a link is a viewer. Yeah, that sounds good. So let me, wait, I because of reasons, okay. So I'm going to copy paste the link on the chat, and I guess I can add it to the video description as well. Okay, there we go. Okay, it's in the video descriptions as of now as well. So thank you folks for being here. And yeah, thank you for helping me. And let's meet tomorrow for more Rust. So happy evening, happy programming, happy hacking, and let's see you tomorrow basically. And again, I do not have a screen which would end this live stream, so I'm going to switch to the one which begins the live stream, and then the stream is going to cut off in a random moment. I need to make that. Thank you to Hebi for being my moderator today, by the way. Yeah. Cheers, folks.